Engineers are in high demand. To decide which opportunities to seize, ask yourself, would I rather develop the robot or design the robotic warehouse? Develop the heat shield or coordinate the space mission? Analyze the airfoil or design the airport? Develop the packaging or create the supply chain? If you answered B to any of these questions, industrial and systems engineering could be for you. Industrial engineers design and operate large complex systems and processes that combine many of the products that other engineers develop. Industrial engineering is a branch of engineering that focuses on making processes better. It's a lot of optimization and making those processes more efficient. Suppose a company has manufacturing plants at locations A, B, and C. It needs to procure raw materials from locations P, Q, and R, which are located on these places. Industrial engineering calculates the best routes to procure raw materials so as to reduce the cost of transportation and save time. Now let us see something different. You have seen a lot of queues in supermarkets at the billing counter. Sometimes the queues are so long that people are reluctant to shop at that place. One way to solve this is to add more billing counters. But it is an additional burden for the company because they need to pay salary to these additional workers. An industrial engineer finds the optimum number of cash counters that need to be placed in the shopping market. An industrial engineer needs to calculate the waiting time of customers during both peak time and not peak times. He needs to consider several factors like salary, space, and many other before finding out the optimum number of cash counters. Let us look at another example. Let's say Amazon is going to build another warehouse that is going to receive 10 million products per week, and it will eventually ship out to people. So it might receive 5,000 orders of product A, 15,000 of product B, and 1 lakh of product C, and so on per week. The problem is, how should everything in that warehouse be designed to make the process of receiving and shipping products the most efficient? How are the trucks going to drop off the products? Should they use forklifts to take the products out of the trucks and pallets, or use more people to unload directly from the truck? What's the time it would take for each? Where should all the products in the warehouse be placed? Let's say if product A and product C are getting the most orders and ship out at the same time, then put them closer to the doors so that people can load the truck quicker. And maybe we put the least ordered product furthest from the door. But what if it is also the heaviest and takes the longest to move? Will that be worth it? This is a question that needs to be answered by an industrial engineer. And a huge career path for industrial engineers would be to help improve and manage the manufacturing process of really anything. Manufacturing applies to nearly every product, including airplane parts, rocket parts, car parts, household appliances, windows, doors, game consoles, hand candy bars, raw soda and bottled water, and so on. Nowadays, manufacturing plants are normally a lot of people, each with their own station, and often conveyor belts that move the product through the plants to the people so that they can do what they need to until the product is complete. As an industrial engineer, you will look at the entire process as a whole, manage it, and figure out ways of how to make it better. So let us take a simple example. Let's say a plant has 2 workers to manufacture paper clips, and let's say there are only 2 steps. The first worker at station A makes the straight piece of steel wire, which takes 2 minutes. Then it is handed off to the second worker at station B, who uses a machine and bends into the paper clip shape, which takes 4 minutes. An industrial engineer comes in to review the process and sees that the second worker will have a pile of steel wires to shape because he is finishing his process twice as slow as the first worker. So if the engineer says we should add a worker to station B, so that way it takes 2 minutes to make the steel wire and 2 minutes on average to shape one. Everything flows smoothly in the same time interval, which means faster shipments and more money. What if we had 10 workers at station A and 20 at station B? Now we can make 10 times more paper clips to ship off, and that is even better, right? But we also have to pay 10 times more people. Is it worth? Based on how much money the extra paper clips make versus the worker's salary. Are those extra paper clips even being sold? that quickly, or have we exceeded the workers we need for maximum profit? What if there was like six stations like in the real world and each person took a different amount of time to finish the job? How would we ensure there is a minimum pileup of work and minimum waiting period? Then you will understand why industrial engineers are so important. This kind of analysis could apply to any manufacturing process from paper clips to buses to fighter jets. Industrial engineers could optimize the distance nurses have to travel to deliver a blood sample to a lab in a hospital, or timing of airplane arrivals and departures at an airport so that there is not a long wait time for the plane and its passengers. Industrial engineering is not always high level math or physics. Industrial engineers look at the efficiency of processes but also the cost of materials and the forecasting of future materials needed, making sure everything arrives on time and in the right quantities, and that the machines are working, and so on. They improve and also manage the process. Also note, industrial engineers don't really do the design work. If you want to make lasers, design radar tracking systems, design spacecraft that can travel faster, design military aircraft, build synthetic body parts, and so on, industrial engineering probably is not the best for you.